In this lecture, we will talk about the transfer well. The transfer well, also known as the insulating well, is a special type of well that is used in the transformer to provide insulation, cooling, and it is contained in the transformer's main tank. It is a mineral well that has been refined to have high dielectric strength, meaning it can resist the flow of electricity, and good thermal conductivity, also meaning it can transfer heat away from the transverse windings. Transfer well must meet up various international standards and specifications to ensure their effectiveness, safety in the electrical equipment. They are subjected to regular testing and maintenance to ensure their quality and reliability in protecting and prolonging the lifespan of the transformers and other electrical apparatus. Extraction of the electrical transverse well. The main sources of the transfer well include both natural and synthetic origins. Let's see some of those sources where we can obtain the transfer well. The first source of the transfer well is the crude oil. This is the most common source of the transfer well, and the crude oil is the raw material that is extracted from the earth. It is a complex mixture of hydrocarbons and other impurities. It is not suitable for direct use in transformers due to impurities, high viscosity and low flash point, and poor insulating properties. Crude oil undergoes a series of refining processes to become stable. These processes include distillation, treatment, hydrotreatment using hydrogen, and additives. After refining, the oil becomes transverse oil with specific properties like high dielectric strength, excellent oxidation stability, suitable viscosity, and high flash point. Next source of the transfer oil is the vegetable oils. Vegetable oils can be used as feedstock for producing bio-based transfer oils. These oils are derived from plants through extraction or pressing processes. Bio-based transfer oils are environmentally friendly alternatives to mineral oils. Vegetable oils are derived from renewable sources and are readily biodegradable. This makes them significantly less harmful to the environment in the case of spills and leaks. Vegetable oils generally have a higher flash point than mineral oil, meaning they ignite at a higher temperature, reducing fire hazards. Common vegetable oils that are used for the transfer oil include soybean oil, sunflower oil, rapeseed oil, coconut oil, and palm oil. The next process where we can obtain the transfer oil is the chemical synthesis. Synthetic transfer oil, including silicone oils and synthetic esters and silicate ester oils, are produced through chemical synthesis. Synthetic oils are manufactured by reacting specific chemical compounds such as organic acids and alcohols to create fluids with desired properties. These oils are engineered to meet specific performance requirements such as high thermal stability, fire resistance, and biodegradability. Natural esters. The next source of the transfer oil is the natural esters. Natural esters are derived from vegetable oil through a process called esterification. Esterifications are essential for creating the triglycerides that can form the base of the natural ester transfer oils. This process involves reacting the vegetable oils with the alcohol to produce esters which exhibit excellent electrical insulating properties. Natural esters are environmentally friendly, biodegradable, making them suitable for use in eco-friendly transfers application. Silicon compounds. The next source of transfer oil is the silicon compounds. Silicon oils is another type of transfer synthetic oil that are derived from silicon, oxygen, carbon, and hydrogen atoms. Silicon compounds are synthesized through various chemical processes, resulting in fluids, exceptional thermal stability, oxidation resistance, and low volatility. Silicon oils are often used in high temperature applications where traditional mineral oils may not be suitable. Let's see the chemical composition of the transfer oil. The chemical composition of the transfer oil can vary depending on the specific type and manufacturer, but it is generally consists of a mixture of different hydrocarbons and additives. The main components of the transfer oil are hydrocarbons, additives, and dissolved gases. Hydrocarbons. The transformers well primarily consist of hydrocarbons, which are compound made of hydrogen and carbon atoms. They are mainly of three types: naphthenic, paraffinic, and aromatic hydrocarbons. Naphthenic hydrocarbons. These are the most common type of hydrocarbon that are found in the transfer well, making them up around 45 to 50%. They have a cyclic structure that gives them good stability at high temperature and resistance to oxidation. Examples are cyclohexane and methylohexane. Paraffinic hydrocarbons. These hydrocarbons have a straight chain structure and make them around 30 to 40% of the transformer well. They have good viscosity properties at low temperatures but are less resistant to oxidation than naphthenic hydrocarbons. Examples are decane and dedocaine. Aromatic hydrocarbons. These hydrocarbons have a ring structure and make up around 5 to 10% of the transfer oil. They have good dielectric strength but are more prone to oxidation than other type of hydrocarbons. Example are benzene and toluene. Additives. Additives are crucial for ensuring the longevity and the optimal operation of the transformers. They help to extend the lifespan, maintain insulation integrity, and prevent operational failure of the transformer. Additives that are added in the transformer oil are listed here. First additive that is added to the transformer oil is the antioxidant. Antioxidants are added to inhibit the oxidation of the oil, which can lead to the formation of the harmful byproducts such as sludge and acids. Common antioxidants include hindered phenols, aromatic amines, and sulfur-containing compounds. Pour point dissipants. These help to lower the pour point of the oil, ensuring it remains fluid at lower temperature and preventing wax crystallization. Corrosion inhibitors. The corrosion inhibitors are included to protect the transformer's metal components from degradation caused by the corrosive substance present in the well or environmental factors. Antifoaming agents. Antifoaming agents are used to prevent the formation of foam in the well, which can interfere with its ability to cool and insulate effectively. Color stabilizers. Color stabilizers are used to maintain the color of the transformer well, preventing it from darkening due to the oxidation or contamination. Dehydrating agents. Dehydrating agents are added to remove the water from the well and reducing the risk of electrical breakdown and improving its dielectric strength. Dispersants. Dispersants are added to improve the dispersion of the solid particles or contamination in the well, preventing their accumulation and deposition on the transverse components. Detergents. Detergents help to clean the transformer's internal surfaces by dispersing and suspending contaminants and preventing the formation of sludge and deposits. Gas absorbance. Gas absorbance helps to remove the dissolved gases such as oxygen and nitrogen from the well, reducing the risk of arcing and corona discharge. Viscosity index improvers. Viscosity index improvers are added to stabilize the viscosity of the well over a wide range of temperature, ensuring consistent performance in varying environmental conditions. The next element that is found in the transfer well are the dissolved gases. Transfer well can also contain dissolved gases such as nitrogen, oxygen, methane. Monitoring the levels of these gases is crucial for assessing the health and condition of the transformer. Let's see some of the key properties of the transformer well. At first, we will talk about the electrical properties. First electrical property that we want to mention is the high dielectric strength. This ensures the oil can withstand the high voltages without breakdown and causing arcing. It is typically measured in kilovolt per millimeter and should be high enough for the transformer's operating voltage. Low dielectric permittivity. This reflects the ability of the wire to store electrical energy with lower values of minimizing energy losses within the transformer. It is typically measured in farad per meter for the transformer. High resistivity. This indicates the wire's resistance to conducting electricity, preventing the leakage currents and improving the insulation efficiency. It is typically measured in ohm meters. Thermal properties. First thermal property we want to mention is the good thermal conductivity. Efficiently transports heat away from the windings and core and preventing the overheating and ensuring the proper cooling. It is measured in watt per meter Kelvin with the high values of signifying better heat transfer. Low viscosity. This allows for easy flow of oil throughout the transformer, facilitating heat transfer, reducing the pumping losses. Viscosity is typically measured in centistrokes at a specific temperature. High flash points. This indicates the temperature at which the oil gives off flammable vapors, providing a safety margin against the accidental fires. It is usually measured in degrees Celsius. Low pour points. Low, it ensures the oil remains fluid at low temperature, crucial for the transformers operating in cold climates. Measured in degrees Celsius, it should be lower than the minimum expected ambient temperature. Let's see some of the chemical properties of the transformer oil. First property is the chemical stability. The oil should not react with other materials in the transformer like metals or paper insulation, preventing degradation and maintaining performance. High oxidation stability resists the breakdown and formation of sludge-like byproducts due to the oxidation over time, ensuring the long service life. Oxidation stability is often measured by standardized test. Low moisture content. The water in the soil can negatively impact its electrical properties and accelerate the degradation. Maintaining low moisture content is crucial for safe and efficient operation. Additional properties. Additional properties include biodegradability, which some synthetic oils offer improved biodegradability compared to mineral oils, contributing to environmental sustainability. Fire resistance. Certain synthetic oils may offer higher fire resistance than mineral oils, enhancing the safety in critical applications. Environmental consideration. Use transfer well if not properly handled. Dispose of can be environmental hazard due to the potential contaminants. Proper recycling and disposal methods should be followed. Thickness and color. Thickness. The transfer well is relatively thin liquid. Its viscosity is carefully controlled to ensure it flows adequately for the purposes while still providing effective insulation. Stickness. While the transfer well is not inherently sticky, it can become contaminated with impurities over time, which may alter its texture. Color. The transfer well is typically clear to slightly yellow in color. It should be noted that the well can change over time due to aging and exposure to electrical stress. Let's see some of the important functions of the electrical transformer well. First function that the transformer serves is the electrical insulation. It prevents the electrical breakdown from arcing between the windings, core, and other conductor parts within the transformer. This is achieved due to the well's high dielectric strength, which allows it to withstand the high voltages without conducting electricity. It is important for preventing short circuits, equipment damage, and potential safety hazards. Cooling. The transformer will act as a coolant by absorbing heat generated by the transformer's core, windings, and due to energy loss. Then the well circulates within the tank and transfer heat to the tank walls, radiators for dissipation to the surrounding environment. It is important to prevent overheating, which can damage the transformer components and reduce lifespan, and efficient cooling ensures the optimal performance and reliability. Moisture control. Transfer wells functions as a barrier, preventing moisture absorption from air and maintaining its insulating properties. Additionally, some wells contain additives that can absorb moisture. It is essential for maintaining electrical integrity and preventing premature transformer failure. Arc suppression. Transformer well has the ability to extinguish arc by readily cooling and quenching the plasma discharge. As the arc comes into contact with the well, the intense heat is absorbed, causing the plasma to lose energy and extinguish. Under high temperature of an arc, the well decomposes, producing gases which may help suppress and extinguish the arc, minimizing the damage to the transformers. Corrosion inhibition. Certain additives in the well act as a corrosion inhibitors, protecting the metal components of the transformer from rust and degradation. Importance. It extends the lifespan of the transformer, reduces the maintenance cost. Dielectric strength. Transformer well has high dielectric strength, allowing it to withstand electrical fields without breaking down. It is important for maintaining the dielectric strength, which is essential for preventing the electrical breakdown, ensuring the insulation integrity of the transformer. Contamination removal. Transformer act as a medium for removing contaminants such as moisture, gases, and particulate matter from within the transformers. The contaminants can degrade the insulation properties of the transformer well and accelerate the aging process. Accelerate the aging process of the transformer components. Additional function includes pressure regulation, which helps to maintain the consistent pressure within the transformer tank by accommodating volume charges due to the temperature variation. Lubrication. In some transformer design, the well can provide lubrication for moving parts. Fire resistance. Certain synthetic wells offer higher fire resistance compared to mineral wells, enhancing safety in critical applications. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section and don't forget to hit the subscribe button. See you in the next one.